Hi everyone, my name is Anavi Nahar and I lead the Azure Load Balancer product group. Glad you could join us today. We'll talk about Azure's Load Balancer options, what suits best for you, and really how you should choose. You'll also hear from my colleague Sergio. With that, let's jump in. Let's start from the basics. Why does anyone even need a load balancer? If you saw my last session at Ignite, I walked you through the journey of building my website for my passion project, golowwaste.com. Now, if anything were to happen to this compute instance, my website would be down. This may sound trivial at first, but let's think about the real-world implications. You're trying to pay your mortgage payment or a bill, and your website for your bank is down. You're trying to get that last item from a store, maybe during even Black Friday, and you're not able to check out. You're trying to play a game and there's a lag. Here's where a load balancer comes in and really helps. A load balancer, as the name suggests, distributes load. I really like to take networking concepts and talk in a way that anyone can understand, even if they're not a networking expert. So let's take an example here. Think of a project. Maybe you're moving from one apartment to another. You have a ton of stuff. If you were to do this all by yourself, you would be overworked, it would take forever, and it would be quite annoying. Now, what happens if you're able to leverage your friend circle? And so you have a couple of friends, or maybe more than even a few friends come in and help you. This way, you won't be as tired, everyone is doing a piece of the project, and things move along a lot quicker. Now think of if there was someone to say, hey, Anavi, you do this. Hey, Matt, you do this. What that means is that someone's able to distribute the load based on certain logic. And that's exactly where a load balancer comes in and helps. Apart from maximizing or optimizing resource use, you're also able to improve availability, because now if something were to happen to those instances, your website or your application is still able to run. Now that you know what a load balancer is, you're probably wondering, okay, but why should I use Azure's load balancers? Why can't I just go create my own load balancer? Well, our load balancers are battle tested. What I mean by that is all of our first-party customers, and you may know them as Xbox, Microsoft Teams, Bing, they're powered by the same technology that powers our load balancers. What this means is that they're tested at crazy amounts of scale. Our security is up to the mark because we take care of patching, vulnerability management, and so on and so forth. We're natively integrated with Azure services. This means you don't have to run the extra headache of management. That also relates to cost. You don't have to spin up separate dedicated instances to do all of these tasks. There's no management overhead. Now, because of all of this functionality, we're also able to offer a rich set of monitoring, metrics, and diagnostics, really offering a complete solution that you don't have to manage and straight out of the box. Our principle at Microsoft is really to empower individuals and organizations to achieve more. And we can only do this by catering to all of our customer workloads. Depending on the type of application that you have, a different type of load balancing solution may be more suited to your needs. Now, everybody has a variety of different needs as they're building different types of applications here on the cloud. We have balance of small, medium, large customers. Everyone has a unique opportunity and everyone needs a unique use case. So with that, I've included all of our load balancers here on the screen for you to see. Now you'll see that I have our traffic manager or our DNS-based load balancer. I will omit it at the end because, hey, you always should use DNS. So really, you should always be using a DNS-based solution. We'll talk more about best practices later on as well, but I just wanted to include it here for completeness. Let's start with our network load balancer or our network layer load balancer, which is nothing but Azure Load Balancer. This is best suited for TCP and UDP applications. You'll notice that with standard load balancer, we also offer HTTPS probes. Now, the reason we did that, and of course we're only talking through standard load balancer here because that's the product that we'll be adding new functionality to going forward. The reason we added HTTPS probes is our customers, pretty much. A good example is that of an IoT-based utility company that has thousands and thousands of metering devices, and they're not able to rely on DNS due to DNS caching issues. So they needed a solution, and this network layer load balancer coupled with the probes is a perfect solution. Now, because this is a network load balancer, it is closest to the stack. that means it has the lowest latency. So any applications that are latency sensitive, think gaming, DDoS protection, so on and so forth, you always want to make sure that it has the little latency. This same technology that powers standard load balancer also powers all of Azure's public IPs. So it's super lightweight and you won't even notice that this is in the path when your applications are running behind it. Think of Azure Load Balancer as a transparent load balancer. What I mean by that is it's not going to do anything to your packets. It's going to just take them and send them based on the appropriate routing logics that we'll talk through and just go on to the next available endpoint. This means that nothing is transformed in your packet and the data is sent as is. With standard load balancer, we also have multiple public IPs. So let's say you need more ports for some reason, or you need a different public IP for a different type of application. Instead of creating a brand new load balancer, you could use your existing load balancer, but a separate front end. This also has cost ramifications, making it super cost effective. The key with standard LB is that we not only give you the power of zones, but we give you the power of one IP powering all across those zones. What I mean by that is, let's say you have an Azure region, which is usually made up of 3 availability zones, or think of them as 3 redundancy layers, so that if a zone goes down, your region or your application running in that isn't down because it's zone resilient or zone redundant. So with standard load balancer, you're able to do this all behind one IP address. So think of how complicated the setup and management and scale would be if you had to do one IP per zone, and then you have a globally distributed application across many regions. That management headache adds up pretty quickly. With Azure Load Balancer, you're able to have one IP that's not only regionally resilient, but also globally, as I'll tell you a little bit later. So the one IP is truly powerful, making your use cases significantly easy, avoiding the management overhead. We talked about the front-end IP and its super powerful use cases. Let's also talk about the other components of a load balancer. Of course, there's the front end, as I mentioned. This could be a public front end, which is what a public LB is, or it could be a private front end, which is also called an internal load balancer, or as an ILB, as I like to call it. We also have a health probe. A health probe is nothing but really telling the load balancer the status of the backend instances. Are these healthy? Are these able to accept traffic? And so forth. Back to my moving example. Is your friend still able to take on more boxes? And if he or she is, then the load balancer will route traffic to your friend. We also have load balancing rules, and these are the rules that use the logic to route traffic. Our usual rules are just called the load balancing rules. We also have 2 special type of rules. One is an inbound NAT rule. What an inbound NAT rule does is, instead of distributing traffic to all of the instances in the backend, you can specify, hey, for anything coming on this front-end IP and this specific port, I want it to only go to this backend instance and no one else. Maybe you have a special workload running on that backend instance. Maybe you have a special type of virtual machine that's better suited for the session that you're running. So in order to enhance and adhere to such flexible scenarios, we came up with the concept of inbound NAT rules on the load balancer. Azure Load Balancer also has a special type of rule called HA ports. HA here stands for high availability. This is super powerful because without this, I would have to create hundreds and hundreds of rules going from one port to the other and mapping that to the back end on a load balancer. So instead of doing that with a lot of rules, I'm able to do that with a single rule. Now this is super powerful for NVAs or network virtual appliances. So think of your favorite provider that you're running with Azure Marketplace in. They're all able to use the power of the HA ports rule under the covers to be able to give you that scale and our collective customers that scale. Super powerful, all you can do with a single rule, so a single click of a button. The final of the components that I wanted to touch on, completing the queue, is the backend pool. Now the backend pool can be virtual machines for a smaller application. If you have a larger application, it may make more sense to use virtual machine scale sets, which means you can auto scale super easily. We've also recently enabled IP-based backends. So let's say you don't know what instance is going to sit in the backend, or you have containers to enable. The flexibility you get with IP-based backends is super powerful, as you're then able to just specify, hey, here's the IP that I want in my backend. Whenever a VM comes up, or whenever a VMSS instance comes up with that, or even when a container comes up with that IP, the load balancer automatically starts probing that, and you don't have to do anything else once you've specified the IP address. It also makes scaling up and scaling down a lot more easy and flexible, and unblocks a lot of container scenarios. Our network load balancer has to make decisions on how to route the traffic. So I know that the instance is healthy, but there's so many of them. So which ones does the load balancer go to? How do I route traffic? And that's where our 5-tuple hashing comes in. Now, 5-tuple is nothing but source IP, destination IP, source port, destination port, and protocol. These 5 tuples, and then a hash is made of them to make sure that this is unique and traffic goes to the right place. Now, in a situation where you might need something called session affinity, so let's say you want traffic from the same session to go there. So back to my moving example. Let's say I start to move a box, and then Brooks comes in and picks that box in the middle of my move, and I'll be really confused because I was going to move that to where it needed to be, right? So you want that continuity to be there. You want to be able to say if an instance has started a project or part of a project, they should be able to complete it fully. So that's really the concept of session affinity, where instead of using the 5-tuple, you can also do a 2-tuple hash. In some cases, the protocol is also important, and that enables also a 3-tuple hash, which is also possible with our network load balancer. Our newest capability is also a global tier. You'll see this as cross-region LB on our docs, but basically what this means is instead of just having a load balancer that's regional, you can now make it global. So take that resiliency piece that I was talking about with zones within zones. So now think of it as adding another layer. So within zones, so in regionally you're redundant, but now even cross regions you're redundant with a single load balancer and a single Anycast IP. Truly powerful, and I encourage you to try this out today. Let's wrap up on network load balancer or Azure LB with all the recent updates. I talked to you about our cross-region support or global tier of load balancer. I also wanted to touch on a recent update of SKU upgrade. We do have 2 SKUs of Azure Load Balancer, Basic and Standard. You're now able to take your basic IP and upgrade it to standard without a change in your IP. This means your IP is preserved. If you have it enabled or enlisted in a lot of your firewalls for ACLing, filtering purposes, that IP no longer changes, but you're able to leverage the rich feature set of standard load balancer with that same IP address. We also talked about IP-based backends, which is also another recent release, unblocking a lot of container workloads. Another pain point that our customers often talked about was resource group move. This is where you want to move your standard resources from one resource group to another within the same subscription. This is more of a management burden, and at least it used to be, but not anymore. We also have Load Balancer Insights fully integrated with Azure Monitor. This means right out of the box, when you use an Azure Load Balancer, you're able to get a rich set of metrics. You're able to get things like traffic flow. Are my backends getting traffic evenly distributed? It also helps with any troubleshooting issues that you may have encountered. We've talked about our network load balancer. Now let's talk about our application layer load balancer, or app gateway, as I like to call it. This really is an HTTP or HTTPS load balancer, making it super, super powerful for all of your application-based load balancing. Application load balancer is very different from network load balancer in the sense that I talked about how network load balancer was transparent, where it just takes the packets and sends exactly where it needs to go based on the routing decision. App gateway is a little bit different. Think of it as more opaque, so to speak. What that means is when a connection comes to the application gateway, it'll terminate a connection and create a new connection to the backend. This unblocks a plethora of scenarios, making application gateway super powerful for scenarios where you want to do things like redirects, URL rewriting, as well as any changes on the headers that you want to make to these packets. Application Gateway is also supports TLS and SSL termination. Cert-based authentication is collaborated with Azure Key Vault. So like I said, our load balancing is fully native with all of the Azure offerings, and this is a powerful example of that. So you can just use your cert that you're using in Azure Key Vault. You don't have to worry about cert rotation. Again, avoiding that entire management headache that comes with making sure certs are refreshed. Of course, we also have auto-scaling support, enabling the true scale of our customers, coupled with availability zone for App Gateway. Just like our network load balancer, our application layer load balancer also has different components. Of course, it has the front end. This can be both public and private, so native to your VNet, completely isolated, just like Azure LB. And instead of the help probe here, it's just a listener. However, it's the same function, right? It's checking if the backend is healthy, is it unhealthy, really what's going on. Similarly, we also have different routing rules for application gateway and a wide variety of them. And I'll talk through these a little bit more deeply. With application gateway, you're also able to specify an FUDN or a fully qualified domain name as part of the backend, making it super powerful for your applications at the application layer. Let's talk about the routing for application gateway. So due to the ability that I was talking about earlier, terminating connections, a lot more routing options or flexibility with routing scenarios are unblocked. You see a few examples in front of you. So let's say you wanted to direct all of the images related to your load balancer. So maybe for my website, golowwaste.com, I had all of the images and I wanted to direct them to a different backend pool because these have specialized virtual machines, whereas video on a different backend pool because they have specialized streaming capabilities, right? You're able to really create these unique scenarios so that you can fine tune the content to really suit your needs using the application gateway. We also have cookie-based session affinity, where same thing, you want that same session to occur, but instead of having session affinity based on the IP, with App Gateway, you're able to do it on the cookie that's saved or cached on your client side. We also have some recent updates for application gateway. Let's take URL rewrite. With this, you're able to query string parameters to modify the response and request headers. So what this really means is, let's say you have a URL coming and you want to rewrite it to something different because the image is hosted on a different URL. Application Gateway gives you that power. So let's say for golowwaste.com, I want to deflect it to another website, maybe images.golowwaste.com or file3041.lowwaste.com. I'm able to do that with Azure's application gateway. Another super cool feature and one of my favorites is wildcard listener. So this really allows you the ability for characters like a question mark or an asterisk in the host name. So anything, so asterisk.lowwaste.com would always go to a certain backend pool based on your routing query or routing algorithm that you have set in. Application Gateway is also natively integrated with our AKS service, or Azure Kubernetes service, and the use of this is enabled by what we call AGIC, or Application Gateway Ingress Controller. So really what this is, it allows our layer 7 load balancer to expose software to AKS. So think of it as an additional hop that would have been previously needed to a public endpoint or a different load balancer. With AGIC or Ingress Controller, this is now completely eliminated, saving a hop on the data path, making your application more robust and optimized for your use case. Traffic Manager, or our DNS-based load balancer, it's kind of in its league of its own, I like to say, and I'll explain why. It really is differentiated because I like to think that you have to have DNS with every IP-based or application. You really don't want to rely on just IPs, and you should be relying on DNS. I have it here for completeness because at the end of the day, it is still a load balancer that Azure offers. Really cool features that differentiate Traffic Manager from our other load balancers. So let's say you're moving from on-premises into the cloud, you're able to just have those endpoints as well. Traffic Manager is agnostic, or I guess it doesn't care about where your endpoints are, enabling a cool solution for hybrid environments. It also has a public endpoint only. This means that if you have a private-facing application, you may want to look at App Gateway or our Azure Load Balancer. It also has 6 different routing methods. The multi-value one is the coolest to me because it enables multiple healthy endpoints returned when you have a DNS query. Catered to more of edge load balancing is our Azure Front Door solution. This uses Anycast protocol and split TCP. Again, this is layer 7 and it's solely internet facing. Now you're probably wondering, okay, Anavi, you also said that our Azure Load Balancer or our Network Load Balancer also uses an Anycast IP address. And yes, that is true. The difference, of course, is that it's network layer versus application layer. Apart from that, the ability to control the IP address as well as client IP preservation, that's something that's not available with AFD or Azure Front Door, but is available in Load Balancer. So AFD is really able to route to the closest endpoints, mainly because it's at our edge location. So let's take a concrete example to make sure you understand the differences clearly. So let's say you have an application that's running and clients connect to it from a variety of different locations, from anywhere really. Now, for a cross-region or global load balancer, that's always entering Azure from the same endpoint. So the entry point is what it decides on what is closest to that endpoint. So based on the entry point, if I'm entering the same entry point from two different locations, Azure cross-region load balancer will route in the same exact way. Whereas AFD is a little bit more powerful in this scenario because it really depends on where our edge location is. So it doesn't matter where the traffic is entering the Microsoft backbone, but really where it's entering the AFD edge location. So this could be really well suited for more latency sensitive applications. Now that I've walked through the differentiating factors with each of our LBs, let's talk about best practices. I said this before and I'll say it again. Always use DNS. Do not rely on the IP address. Always use DNS. Another caveat that may occur as you're thinking about best practices and building your application in Azure, you want to be aware of DNS caching. What this means is, let's say an endpoint goes down, DNS for a certain period, or the TTL, will continue to route traffic to an unhealthy endpoint because it's relying on something that your device has called a DNS cache. Now, of course, if you just retry or re-resolve, this would fix that issue. So that's definitely a best practice that you want to keep in mind as you're building an application from your client side of it. Other best practices that you want to keep in mind as you're thinking about building your application and using Azure's Load Balancer product suite, think about a few things. Nature of application. Is it regional? Is it global? Does it matter that where it enters the Azure location? Are you latency sensitive? What is the type of workload? Is it on-prem only? Is it Azure only? Is it a hybrid environment? You want to make sure you're able to consider that because that would distinguish which load balancer you're able to select. Similarly, latency. I touched on this a little bit earlier, how the network load balancer only cares about where the traffic enters the Azure backbone, whereas AFD cares more about, hey, where are you getting to the closest edge location? So this could have significant implications on your end workload. And of course, last but not the least, cost. You want to always optimize for cost in the cloud, and we understand that. And so we've catered our solutions in different price points to really meet all of the workloads, whether you're small, medium, or a large corporation. With that, I'm going to transition over to my colleague Sergio to tell you more about the latest that we're doing to integrate all of this in a streamlined portal experience.
Thanks, Anavi. So my name is Sergio Figueiredo. I'm the lead for Azure Networking Portal and also for Docs. And as you might have heard in the keynote, we talked about the Azure Load Balancing preview. So a new experience that we're going to have on the portal. And what this experience really is trying to do is to simplify the way that you choose your load balancing options. Because as you've seen, Anavi mentioned so many different options across all of these four different services that it just makes it really hard to make the right decision based on best practices and architectural guidelines. So what we want to do is provide you with a guided experience. You go through a questionnaire in the portal, and we actually walk you through with links for learn modules, videos, and even also a comparison matrix with all the different features from the different services, where you're going to be able to choose the best load balancing service for your application. And also another thing that we do is we try to increase the discoverability of all of these services. So we have everything nicely fit into this centralized location in the portal, where every time that you provision a service, be it a load balancer, be it an Azure Front Door, Traffic Manager, App Gateway, you just click on that experience and you're going to be able to see everything on a single central location. So the cognitive load is going to be reduced to just a simple set of questions, and we're going to offer you there an architecture which is based on best practices. And really what I'm going to do next is to give you a walkthrough in the portal where you're going to be able to see what it looks like. So now I'm going to transition to the Azure portal where I'm going to walk you through the actual experience.
So if you actually go into the portal today and type in load balancer and you go load balancing help me choose, you'll notice that essentially we have this new help me choose functionality. So off the bat, one of the things we wanted customers to be able to identify are, hey, what are the 4 different load balancing services in Azure, and what are the differences between them? So off the bat, you'll notice that we have like 3 bullet notes in these different tiles that highlight the differences between them. But if you click on any one individually, you'll notice that we have a plethora of links to the most relevant information in docs. That includes, again, the information to like the high level application gateway docs, but also the key features, security and monitoring, because we always know that's important. Reference architecture for you to be able to tell, hey, how do I actually use this application within my environment globally? And pricing, because that's always important as well. So again, all of these different tiles will have all this information. And also you will notice that we have a questionnaire up here. So as we enter the questionnaire, so does your application use HTTP, HTTPS? If we answer yes to that, you'll notice that some of the options get filtered down. So by answering these questions, we're trying to really hone down on what is the best resource for you. So as we continue to answer these questions, is your application public facing? We'll say yes. Is your application deployed in multiple regions? Yes. Do you want performance acceleration? Again, my customers are important, so I'm going to say yes. Do you want SSL offloading or application layer processing per request? Now, if these questions become a little bit too technical for you, one thing to keep in mind is if you actually want to go learn about these resources, you can always click on the service itself. And if we're going to ask you a question about it, most likely there will be some documentation explaining it. So both application gateway and front door will have that available for you. But for this application, let's say I know about it and I don't want it. So I'm going to select no. And is your application hosted in PaaS? Yes. At this point, you'll notice I finished the questionnaire and I get a recommendation. And apparently Azure Front Door is the best resource for my service. And at this point, again, it's a great time to click on reference architecture to go see how this architecture will fit into my resource. Now, let's say if you actually want to say, hey, I don't want just to be told which service is for me. I actually want to see what the differences are for myself. At that point, you can go into the service comparison. The service comparison has a comparison of all the different resources across the most high level and most important feature sets. So again, for load balancing, some of the most important ones would be, hey, what are the supported protocols for your application? Does it support private or global? What are the routing policies, etc.? And we'll continue to update this grid as more features come out for the different services. So you always get the most up-to-date information here as well. Now, for some customers, although being able to kind of like see at a high level is helpful, you might actually want a more like in-depth experience. And for that, we have a tutorial section. So let's say if you actually want to go learn more about application gateway for your particular service, you can click here and we'll direct you to the MS Learn resources where you can kind of like see the docs themselves and you can spend an hour and a half in a more structured format and a more comprehensive format than what we've previously seen. And again, if you actually want also like shorter videos that are helpful, for example, how to create a load balancer, that is here as well. And finally, you'll also notice over here on the left, we have the different load balancing services here. And here you'll notice that the browse experiences are here. Now, this isn't out yet, but in the future, later this year, we are planning on releasing a feature to essentially drive all the browse experiences for these different services to here. So from now on, if you actually go here and type load balancer, and actually select this experience, it will direct you directly to here instead. So the overview and all the information that it has will be always readily available. And yeah, so hopefully you guys can go play with this experience and you guys will enjoy it. Thanks.
Thanks, Sergio, for showing us the true power of what you can do with this integrated experience that's currently in preview and we're launching super soon. So we definitely encourage you to try it out. I wanted to end with a couple of slides. One is a load balancing comparison. This is just an eye chart highlighting other differences that you may want to keep in mind. IPv6 could be a factor, private link could be a factor, things like site acceleration. So each load balancer is really catered to a differentiated set of scenarios that we want you to leverage to make sure you can make the most out of the Azure platform for your application. Here's some resources in our landing page for our latest Azure Load Balancing homepage. Take a look and learn more. Thanks so much, everyone. I hope you enjoyed this.